Hello. Today we are going to be looking at probabilities from tables and also something called conditional probabilities. That's where, well, if I tell you this, can you figure out the probability? Okay, so I have an example here on our screen, and let me just read this to you. In a class of students, the following data table summarizes how many students passed the test and completed the homework due the day of the test. What is the probability that a student chosen randomly from the class completed the homework? So there are two questions. Did you do the homework? And that's a yes or a no. And did you pass or fail the test? And so that puts people in these four different categories. So if you look at the 10 right here, the 10 is there are 10 kids who completed the homework and they passed the test. If you look at this 5 over here, these 5 kids completed the homework, but they failed the test. These 2 kids completed the homework, or I said that wrong. They did not complete the homework, but they still passed the test. And then these last 4, they didn't do the homework and they failed the test. So, and that's how you understand the data. I wonder if from this we could figure out how many kids are in this class. Well, we had 10 kids here, 5 over here, that makes 15. Another 2 kids here, so that's 17. And then 4 more. So we're talking 21 kids in this class. So we have 21 kids. I think I'll put that over here. 21 kids. Now let's go back to this sentence and read the question that we're asked. What is the probability that a student chosen randomly from the class completed the homework? Well, how many kids, if you said, did you complete the homework, how many would say, yes, I did the homework? Well, that would be these 10 kids and also these 5 kids. All of those kids completed the homework. So how many kids completed the homework? That's right, that's 15 of them. So 15 out of the 21 kids completed the homework. So if we want this as a fraction, it would be nice to reduce it. So those are reducible by 3s. So I could call that 5/7 of the kids. If you want that to be in a percent form, we often give probabilities as percents. You could change that into a percent. So we'd be at 71.4% roughly as the percentage rate of completing the homework. So there's that problem. You will also see some today. Let's see what this one says. In a class of students, the following data table summarizes how many students play an instrument or a sport. What is the probability that a student chosen randomly from the class plays a sport or an instrument? So they have 2 questions. Do you play a sport? And that's a yes or a no. And then do you play an instrument? And that's also a yes or a no. So to understand our table here, these 5 kids right here, they play a sport and they play an instrument. The 2 that are over here, they play a sport, but they don't play an instrument. The 4 that are down here, they don't play a sport, but they do play an instrument. And then these last 12 kids don't do either one. They don't play a sport, they don't play an instrument. So our question, if I go back up here to the question again, it says, what is the probability that a student chosen randomly from the class plays a sport or an instrument? So these 5 kids, do they play something? Yes, they do. They play both, actually. These 4 kids down here, they don't play a sport, but they do play an instrument. So they play something, they count. Oops. So I'm trying to circle them in blue. But they count. The 2 kids over here in green, they play a sport. They don't play an instrument, but they do play a sport, so they count. But those purple kids, they don't play either one. They don't play a sport or an instrument, so we're not going to include them in our total, or in our number of kids who play a sport or instrument. So it looks like I have 11 numbers circled there for kids who play something. Now, how many kids are in this class? There's those 11 that I have circled, but then there's also those 12. So if you count those up, 11 plus 12 would be at 23 kids. Again, if you wanted a percent, you could divide top by bottom to change it to a decimal and then move it over to for the percent. Let's see what our next page is. In a class of students, the following data table summarizes the gender of the students and whether they have an A in the class. So again, two questions. Are you a boy or a girl? And do you have an A or not? Well, what is the probability that the female student does not have an A? So I want to know the likelihood that a female student, so I only want to look at the girls here. So what that means is I don't care about these guys. Sorry, guys. But this says I want to know the probability that a female student does not have an A. Well, how many of these girls don't have an A? Well, that would be 2 of them out of, how many girls are we talking? 5. So 2 out of 5, that's a 40%. Another problem you might see is something like this. In a class of students, the following data table summarizes how many students have a cat or a dog. So they ask, do you have a cat? Yes or no. Do you have a dog? Yes or no. What's the probability that a student has a cat given that they do not have a dog? Okay, so this is where we're moving into conditional probability, and it hinges on this word given, okay? Or sometimes you'll see if included in this. But I want to know how likely is it that I have a cat, but I'm already telling you these people do not have a dog. So that means I can disregard these people because they have a dog. I already know the ones that I'm talking about do not have a dog. So I'm only looking at how many kids total here in my chart that are possible since they don't have a dog. Well, that would be 12. If you count them up, that's 12 kids. That's going to be my denominator. So something out of 12. What's the probability that a student has a cat? So of these 12 kids, how many said, yep, I have a cat? Well, that would be these 2 kids. So 2 out of 12, you can reduce that to 1/6. So that's what we say conditional probability is. There's a condition on this. I'm not talking to everybody here. I only want to talk to you if you do not have a dog, because it's given that we do not have a dog. So we're already saying the rest of you, whatever. I'm talking about of the ones that don't have a dog, do you have a cat? So another problem that would look like that, or be related, is in a class of 30 students, 6 play an instrument, 17 play a sport. There are 9 students who do not play an instrument or a sport. What is the probability that a student chosen randomly from the class plays neither a sport nor an instrument? And whew, that is so much information. The other ones that we've seen have our information already organized in a table, and this one is just all words, and it would be a lot easier if we could see it as a table. So let's break this down here. So we have a question about if they play an instrument, and then another question about if they play a sport. So let's make a little table here. So yes, instrument. I'm going to abbreviate because that's too long of a word. And this is going to be no to the instrument question. And then we will have up here, yes, I play a sport, or no, I do not play a sport. Okay, so those are the framing categories that we can have here. So we've got 30 kids all together. So what that means is if you add up all of the boxes, there would be 30 in all 4 of these boxes. I'm going to frame this out a little bit. And I'm going to extend these so I have some room to work. Let's see. Let's get our data. We have 6 kids who play an instrument. So what that means is if I look at just the yes row. Yes, instrument row going across. I know that those two boxes would add up to 6. So I'm going to put a 6 over here in the margin. What that means is if I add across, I would get a 6 for those two boxes. Now there are 17 who play a sport. Well, the sport is my columns, and the left column is the one that says, yes, I played a sport. So that those two boxes would have to add up to 17 if I added up and down here. Those two are the yes sport people. There are 9 kids who don't play an instrument or a sport, so they are no kids. So these kids are right here. There's 9 of them. Why did it freeze? Okay, well, we have 30 kids in this class, and I want to focus on the 6 who play an instrument. If I got 30 kids, and I say, who plays an instrument? 6 kids raised their hand. How many didn't? How many raised their hand that they don't play an instrument? Well, there's 30 kids altogether, 6 play, so the rest of them don't. That would be 24. So there are going to be 24 kids here in this I don't play an instrument line. Now, if I know there are 24 kids there, and, oh no, let me do one more thing first. Let's think about the sport people. So I'm going to ask my 30 kids in the classroom, do you play a sport? And 17 of them say, yes, yes I do. How many kids didn't raise their hand? There's 30 kids in the room. 17 said yes, so the no's would be 13. So I'm going to have a 13 right down here in my chart. So you can use this as a double check. The 6 plus 24 adds up to 30 kids, and then the 17 plus 13 also adds up to 30 kids. So that's going to cover all 30 kids in the class. So I want to do some work backwards information now. So I want to look just at let's look at the no sport column. Okay, so I'm covering up the rest of the chart just so I can see the column that says no sport. I know that there are 13 kids that don't play a sport, and 9 of those are in the no instrument category. How many does that leave in this box right here to be yes instrument kids? There's 13 kids in this column. 9 of them are already accounted for. That leaves 4 up here for playing an instrument but not a sport. Let's go across. Let's go across the yes instrument column. So the yes instrument, there were 6 kids in the class that play an instrument. I've already counted for 4 of them, so how many does that leave over here? Well, that would leave 2 kids. So those 2 kids play an instrument and a sport. Let's look, we can look at a column or a row at this point. So I think I'm going to look at this column of the yes sport column. So there's 17 kids total who say yes, I play a sport. I've already accounted for 2 of them in that column, so that leaves 15 kids here. So what a nice double check is, if you add up these 4 numbers, we should end up with 30 kids because it should account for all of our kids. And it does, so we're good. So we just took all of those words and changed them into a table. Now let's see what they ask us about. It says, what is the probability that a student chosen randomly from the class plays neither a sport nor an instrument? So I'm looking for the no kids. They don't do either thing. No sport, no instrument. Well, there's 9 of them. And how many kids are in the class? Altogether, 30. So we're talking 9 out of 30. You can reduce by 3s and call that 3/10, which is 30%. So there is that. Here's another question that is similar to this. We have a math class of 21 kids. A test was given the same day that an assignment was due. There's 14 kids who passed the test and 16 who completed the assignment. There were 12 who passed the test and completed the assignment, and we want to know a probability. There's too much information here when it's in story form. If we can see it organized as a table, this will be much better, so much better. So to make our table, we have 2 basic questions. One is, did you do the assignment? And the other is, did you pass the test? So we'll put the test up here. Test, pass, test, fail. And the assignment over here. So if they did the homework, yes, yes, homework, they did it, and no homework, they did not do the homework. So that's supposed to be an H. Homework, there we go. So we got 21 kids in the class. So let me extend my boxes a little bit here so I have room to put my totals. So total, I'm going to have 21 kids. There are, let's see, 14 students who passed the test. So the test is the columns. So which column do I want? The ones who passed the test. Is that the left-hand column or the right-hand column? Well, that would be the left-hand column. So I need 14 kids in this column. So I'm going to put a 14 down here. So pause. I'm going to pause there this time. So can you figure out how many kids failed the test? Have I given you enough to figure out that? Well, yeah. If there's 21 kids in the class and 14 of them passed, the rest of them didn't. So that would be 7 kids left. So I'm going to put a 7 right there in the test fail column. There are 16 kids who completed the homework assignment. So the homework is going across in our rows. And 16 of them said, yeah, I did it. So that 16 is going to go right here. So if I add the 2 numbers in that row, I'm going to get a 16. Is that enough for you to know how many kids didn't complete the homework? Remember, you got 21 kids sitting in this classroom. So 21 kids total. 16 said, yes, I did it. How many didn't? Well, the rest of them, that would be 5 kids. There are 12 students. So I'm in this, the sentence right here. There are 12 students who passed the test and also completed the assignment. So those 12 are, yes, I passed, yes, I did the homework. They go right here. And if you have that fact, you can figure out everything else in the table. Because if there's 12 there, I'm looking at the column right now, and 14 need to be in the column, that's going to leave 2 kids here. Now I'm going to go across. If I look at the 12 and a blank, and I know it needs to be 16, that means I'm going to have 4 kids here. And then in the no homework row going across, if I have 2 and a blank, and I know it needs to make 5, it means that I need to have a 3 right here. So check all the colored numbers, add up all the colored numbers, and see if it adds up to all 21 kids being accounted for. So the 12 plus the 4, that's 16, plus 2 more, that's 18, plus 3 more. Yep, that gives us our 21 kids. So now we're ready to find a probability. What is the probability that a student chosen randomly from the class passed the test or completed the homework? So you get to say woohoo if you did either one of those things. So did these 12 kids, did they pass the test or complete the homework? Yeah, actually they did both. They're the superstars. Good job, kids. So what about these 4 over here? Did they pass the test or complete the homework? Well, they did do the homework, so good job on the homework, kids. You get included. What about these 2 down here? They didn't do the homework, but they passed the test, so they get included as well. But those 3, they didn't pass the test or complete the homework, so we don't want to count those kids. So it looks like if I look at my circle numbers, I have 18 out of the 21 circled. So 18 out of 21 reduces by 3, so you could call it 6/7. And if you wanted a percent, you could do it. So you have a Delta Math assignment, and these problems were from Delta Math, so it'll be real similar to what you see there. And remember that Jesus loves you, and so do I. So do your math.